All right, let's talk about the one piece of tech that I guarantee is within a few feet of you right now. It powers our phones, our cars, our entire modern world. We're going to crack open the unseen engine that makes everything tick. Yeah, we're talking about batteries. That really hits the nail on the head, doesn't it? We just don't think about them. But these little powerhouses are quietly running the whole show. Without them, our world would literally just stop. So before we jump into all the crazy future tech stuff, let's just take a second to appreciate how deeply batteries are already woven into, well, everything we do. I mean, just look at the scale here. It's so much bigger than just the phone in your pocket. We're talking about electric vehicles, obviously, but also these massive, and I mean massive, battery farms that help keep our entire electrical grid stable. They're in space, powering satellites, and they're absolutely essential for making renewable energy like solar and wind work, storing that power for when the sun isn't shining.
So how does this magic actually happen? Well, at its core, a battery isn't magic at all. It's actually just some really, really elegant chemistry. So let's break down how it all works.
Every battery you've ever seen, from the tiny one in your watch to the giant pack in an electric car, is really just a collection of these things called electrochemical cells. Think of them as the basic building blocks. Their only job is to take stored up chemical energy and turn it into the electrical energy that we can actually use. And inside each cell, you've got two main characters, the anode and the cathode. The easiest way to think about it is like a racetrack. The anode is the starting line. It's just packed with electrons, raring to go. And the cathode? That's the finish line. It's where all those electrons desperately want to end up. But here's the trick. The electrons can't just jump straight from the anode to the cathode inside the battery. They're forced to take the long way around, through whatever device you've plugged in, and that's what powers it. So, what's going on inside the battery to keep things balanced? That's where the electrolyte comes in. It's like a special highway that only lets ions, not electrons, travel across. It completes the circuit internally so the electrons can keep doing all the useful work externally. Now, for decades, batteries were fine, but kind of clunky. Then, one specific type of chemistry came along and completely changed the game. It unlocked the entire world of portable, powerful electronics that we now take for granted. This was the lithium-ion revolution. And to really get why lithium-ion was such a breakthrough, you have to understand this one crucial idea: energy density. This is everything. It's basically a measure of how much juice you can cram into a battery of a certain weight. The higher the energy density, the more power you get from a smaller, lighter package. Simple as that. And this chart just lays it all out plain and simple. Think about the old-school lead-acid battery that starts your car. Super heavy, low energy density, and you can't recharge it that many times. Now look all the way over at lithium-ion. We are talking about a massive jump in energy density. This is what made it possible to have a device in your pocket that could last all day. It's not just a small improvement, it was a total game changer. So what's the secret sauce? How does it work? It's all about a really clever process called intercalation. Honestly, the best way to picture it is like a multi-story parking garage. The anode and the cathode have these amazing microscopic structures that let lithium ions just slot in and out perfectly without damaging anything. And because they can park and unpark so gently, you can do it thousands of times. That's what makes these batteries so durable and rechargeable.
Okay, so the chemistry is brilliant, but how do you go from a cool science concept to a safe, reliable product that we can all use every day? Well, that's where some seriously incredible engineering comes into play.
Building a modern battery cell is kind of like being the world's most precise chef. You mix these special powders into a paste, you coat it onto foil thinner than a human hair, you stack it or roll it all up with zero imperfections, and then you bring it to life with its very first charge. Every single step has to be absolutely perfect. And there's a very, very good reason for all that precision. Because when you pack that much energy into such a tiny space, you have to ask, right? What happens if something goes wrong? This is the nightmare scenario for every battery engineer out there. It's called thermal runaway, and it's a terrifying, vicious cycle. Something makes the battery get a little hot, which triggers a chemical reaction that creates even more heat, which makes the reaction go faster, and on it goes. It's the #1 safety challenge. So how do you stop that from ever happening? You give the battery a brain. And that is exactly what the battery management system, or BMS, is. Think of it as a tiny little computer that acts as the battery's bodyguard. It's constantly monitoring the temperature, the voltage, the health of every single cell.
And if it senses the slightest hint of trouble, it can shut things down in a fraction of a second. It is the unsung hero that keeps these powerful devices safe. Lithium-ion is king today, no doubt about it, but the story is far from over. All around the world, scientists and engineers are in a massive race to figure out what comes next, to build batteries that are even cheaper, safer, and way more powerful.
And a really strong contender is the sodium-ion battery. Now, just look at the trade-offs here. Its energy density is lower, so you're probably not going to see it in a high-end smartphone anytime soon. But, and this is a huge but, it's made from materials that are super abundant and cheap. I mean, sodium is literally in table salt. This makes it an amazing candidate for things like grid storage, where cost is everything and weight just doesn't matter.
And if you look even further out, oh man, things get really exciting. You've got solid-state batteries, which could be a huge leap in safety and power. People are working on new chemistries like lithium-sulfur. And there's a huge push for advanced recycling to create a circular economy so we can reuse these precious materials over and over again. It's all about making batteries better in every single way.
At the end of the day, a battery is so much more than just a component in your phone. It is a fundamental key that unlocks the future. Think about it. Electric airplanes, truly smart and resilient power grids, technologies that we can't even imagine yet. All of it depends on our ability to store energy. The next great leap for humanity is tied directly to what's happening inside that tiny little electrochemical cell. The question isn't if the next battery revolution will happen, it's what amazing things it will let us do.